Hello, this is going to be a continuation of the test review for the graph table rule, multiple representations. Right, the other side of this page was this graphic organizer. So we're going to look at this page here together and kind of take ourselves through what's happening here. So we got a store sells t-shirts for $12 each and sweatshirts for $15 each. And we plan on spending $120 here on these t-shirts and sweatshirts. So write and graph the equation that represents the situations. What are three combinations of t-shirts and sweatshirts we can buy? Now this is telling us that we need to get this set up into a standard form here, right? Because if it's $12 for each t-shirt, I'm going to put a 12x. And if it's $15 for each sweatshirt, and we plan on spending $120, right, here's a word problem setup using that standard form where X is number of t-shirts. So this is us labeling our variables. All right, and Y is the number of sweatshirts. All right, so with this, you wanted us to also graph this information, talk about three different whole number combinations. So what I'm going to do here is I'm going to go through and I'm going to check out for my X and Y intercepts. That's what I'm going to use to help myself graph this. So if I'm looking for my X intercept, I know here that I'm going to have a 0 in the y direction. When I plug the 0 in for this y, I'm just left with 12x is equal to 120. Now when I divide both sides by 12, I get my x-intercept is a 10. Now for our y-intercept, I know that my x-coordinate is guaranteed to be a 0. When I plug in that 0 for this x, all I'm left with is that 15y. We got 15y is equal to 120. And so when I divide both sides by that 15, you get an 8. All right, so I'm going to use this knowledge here, my x-intercept and my y-intercept, to make a graph here. Now let's get these scaled out. X is t-shirt. Y is sweatshirt. So we see those two components. I'm going to go ahead and get my graph scaled and labeled here for us. All right, I'm going to be counting by 2. So we've got 2, 4, 6, 8, 10. We'll go up to 10 there for our sweatshirts, right? That's going to be my x. All right, we'll scale out our y. All right, so we've got this here. Here's our x-axis. Here's our y-axis. Now plotting my x and y-intercept. My x-intercept is at 0, 10. My y-intercept is at 0, 8. Now using a straight edge, if we connect this with a perfectly straight line here, a straight edge slipped on me there for a second. All right, and it's asking us for three different combinations of t-shirts and sweatshirts we can buy. We've already found two of them, and then one additional point we can see would be right here. All right, which looks like if I sell, so this third additional point would be I sell 4 t-shirts and I sell 5 sweatshirts. That would be another coordinate point that we found by graphing. It's an exact crossover process. All right, and so that's that first problem. So we'll go ahead and keep moving through the rest of this here. It gives us some coordinate points, wants us to find the slope. That's us using our y2 minus y1 over top of x2 minus an x1. We're going to find our slope. Start off with that slope template. I've got a negative 6, subtracting a negative 18 over top of a 0, subtracting an 8. And we'll talk about what number this gives us. Double negatives turn positive, so negative 6 plus an 18, that's taking me to a 12. Over top of here, 0 minus 8 is a negative 8. All right, now I can simplify this fraction. Right, because 12 divided by that -8 there, I can divide them both by 4. So my slope answer here, if I divide both of these by 4, simplify this fraction, is going to be 3/2, and it's negative. Right, this is our slope that we have found through those 2 points. Right, now it wants us to write an equation in point-slope form. This is using our y minus y1. Right, now for this, I'm going to go ahead and I'm going to I'll use this first corner point. We could choose either one. I'm going to put a y plus 18 is equal to our slope of -3/2 times our x minus an 8. All right, now here's where this came from. I listed this as my x1 and this is my y1. Right, and I put it into our point slope. Just remember our point slope is y minus y1 is equal to our n times our x minus x1. The reason this turned positive is because it became a negative with the formula and a negative with our 18 there. All right, so writing that equation in slope-intercept form, there's 2 ways we could do it. We could plug different values into our y is equal to plus b to find that b value, or we could recognize here that my y-intercept was already given to us. I know that my y-intercept is -6. So I can just do y is equal to take our slope, -3/2x, and subtract a 6 there. That would be our equation. And that'll happen sometimes. Sometimes they give you that y-intercept. Now, in terms of our finding the x-intercept and y-intercept, we just discussed they already gave us that y-intercept. We recognize that because it was 0 in the x direction. Now, for that x-intercept, that's where we need to go through, and we're going to have to plug in 0 for our y. Now, we're used to doing this with standard form, which is something that we have seen, but for this time, we have to go through and identify it off of this equation here. Or we can also choose to graph the line and see if that helps it find us, right? There's multiple representations, so we can find these different pieces of information multiple ways. All right, so let's graph this line, see if maybe our x-intercept shows up that way. Maybe it's a whole number. Maybe it's not. So we have our y-intercept -6. Now my slope here for us is a -3/2. Tell me to go down 3 to the right 2. Down 1, 2, 3 to the right 2. Or we can choose to do the opposite of this. I can go up to the left as well. You see if I go up 1, 2, 3 to the left 2, that I still fall on this same line here. Now if I go up 3 to the left 2 again, now we have found our x-intercept. We found it through graphing this time, which is fine, and it's at a -4. Same thing we would have gotten as if we would have plugged a 0 here in for our y and solved this equation out for x, right? Or we found it in this case by graphing. So we could take a straight edge here, and we could draw our line. Right, now some of these different things, we have to find them differently on that test that we'll be looking at, but this is just a good multiple representation review kind of wrap up. Some of it's a little harder than what you may see on the test, some of it might be a little easier. We'll be sure to look back at all notes and things of that nature to